Hey everyone, welcome to the GNT Creator channel. My name is Makita and I'm really glad you're here. In this new playlist, we're going to dive into one of the most popular and powerful programming languages in the world, Java. Whether you're completely new to the coding or you already have some experience and want to strengthen your fundamentals, this series will guide you step by step from the very beginning all the way to writing real-world Java programs. In this first video, I'll walk you through the following topics: what Java is and why it's such a powerful programming language, the key components like JDK, JRE, and JVM, how to set up your Java and IntelliJ IDEA environment on Windows and macOS, how to write, compile, and run your very first Java program, and much more. So grab your laptop, follow along, and let's get started learning Java. Alright, before we start writing code, let's take a few minutes to understand what Java actually is and why it's still one of the most popular programming languages in the world. Java is a high-level object-oriented programming language created by Sun Microsystems in the mid-90s and later acquired by Oracle. It was originally designed to let developers write programs that could run on any device without needing to rewrite the code for different systems. Today, Java is used everywhere, from web applications and Android apps to banking system, backend servers, and test automation frameworks like Selenium. So, if you're learning Java, you're learning a language that powers a huge part of the software world. Now, let's look at the few key features that make Java so powerful and widely used. Object-oriented. Everything in Java revolves around objects and classes, which makes your code easier to organize, reuse, and maintain. Platform independent. This means that Java code can run on any operating system, Windows, Mac, or Linux, without changes. Robust and secure. Java has strong memory management and built-in security features that make it reliable for large systems. Multipurpose. You can use Java for almost everything: web development, mobile apps, enterprise software, test automation, and more. Also keep in mind that Java is a case-sensitive language. This means that when you declare the variables, for example, n lowercase and n uppercase, two separate variables will be created. Write once, run anywhere concept. One of Java's biggest strengths is its idea of write once, run anywhere. Here's what that means. When you write a Java program, it's first compiled into something called bytecode, not machine code that only works on one system. This bytecode can then run on any machine that has a Java virtual machine or JVM installed. So you can write your code once and it will run the same way everywhere. That's a huge advantage for developers and one of the reasons Java has stayed so relevant for decades. Let's take a look on Java architecture flow. This simple flow shows the power of Java architecture. You write Java source code in that Java file. It gets compiled into bytecode.class file. The JVM reads and executes that bytecode on any platform. We'll talk more about the JVM, JDK, and JRE later. But this gives you the big picture of how Java actually works behind the scenes. Why Java is an object-oriented language? Now that we know what Java is, let's talk about one of the most important reasons it's so powerful and widely used. Java is an object-oriented programming language, or simply an OOP language. So what does object-oriented mean? Object-oriented programming means that your code is built around objects, not just actions or functions. An object represents a real-world thing, for example, a car, a bank account, or a user profile, and it can handle both properties, data, and behaviors, methods, or actions. This approach makes large programs easier to build, maintain, and scale because you can model complex systems just like you would in the real world. Main OOP concepts in Java. There are four main pillars of object-oriented programming. You don't have to memorize and understand the meaning of each one of them right now. We will cover this topic later. For now, just keep in mind that those concepts exist: encapsulation, inheritance, polymorphism, and abstraction. If the programming language supports all of those concepts, it can be considered as a object-oriented programming language. Java is considered as object-oriented programming language because almost everything in Java, from classes and variables to methods, revolves around the concept of objects. There are three main categories for programming languages: object-oriented, where code is structured around objects and classes like Java, C++, Python, C Sharp, Ruby; procedural, where code is structured around procedures or functions like this is non-OOP, for example, C, Pascal, or Fortran; and functional or hybrid, combine object-oriented and functional paradigms like JavaScript, Scala, and Go. For now, just remember that Java is object-oriented programming language. Alright, now that we understand what Java is and why it's such a powerful language, let's talk about the three core components that make the Java ecosystem work: the JDK, JRE, and JVM. Let's start with the JVM, or Java Virtual Machine. The JVM is the heart of the entire Java system. Is the engine that actually runs your Java programs. Here's what happens behind the scenes. When you write a Java file, for example, hello world.java, it first gets compiled into something called bytecode, that class file. The JVM then reads and executes that bytecode line by line. Because every operating system, Windows, macOS, or Linux, has its own version of the JVM, your same Java program can run anywhere. That's what makes Java platform independent. So you can think of the JVM as a translator. It takes your Java bytecode and translates it into machine code that your computer understands. Next, let's move to JRE, or Java Runtime Environment. The JRE provides everything the JVM needs to run a Java application. It includes the JVM itself and core libraries like classes for strings, math, collections, etc., supporting files that help your program execute. You can think of the JRE as the container or environment where your Java program lives and runs. If you only want to run Java applications on your computer, not write or compile them, the JRE alone is enough. So JRE contains JVM plus core libraries. Finally, we have the JDK, or Java Development Kit. This is the toolkit that developers or automation testers like you and me actually use to write, compile, and run Java programs. The JDK includes JRE, JVM, and additional development tools like the Java compiler, debugger, and documentation tools. So when you install Java for development, you're actually installing the JDK because it contains everything needed to both develop and run Java programs. Again, right? JDK contains everything, JRE contains JVM, and JVM is an engine. Here is an easy way to remember it. The JVM is the engine, it actually runs your code. The JRE is the car, it provides the environment for the engine to work. And the JDK is the factory, it gives you all the tools to build the car in the first place. So, to recap, JDK is a Java development kit used by developers to write and compile code. JRE is a Java runtime environment, provides the environment to run Java applications, and JVM, Java Virtual Machine, executes the bytecode and makes Java platform independent. All three work together to make Java development possible, and we'll be using the JDK and JVM when we install and configure our environment in the next part of this video. Why do we even need JDK, JRE, and JVM? How do they work? Let me give you a high-level overview of the process. Step number 1, write in the source code using the JDK. When you start coding in Java, you're using something called the JDK, or Java Development Kit. The JDK is a collection of tools that help you write, compile, and debug your Java programs. It includes everything you need to develop software, as we discussed earlier. So when you open your IDE like Eclipse or IntelliJ and start typing your program, you're working with the JDK. The file saved as, for example, hello world.java is called source code. It's written in human readable Java syntax. Step number 2, compilation, turning code into bytecode. When you hit run, the Java compiler, which part of the JDK, gets to work. It translates your Java source code into a special format called bytecode, which is saved in a .class file. The setup doesn't produce machine code yet. Instead, bytecode is a sort of universal language for the Java platform. It's designed to be executed by the Java Virtual Machine or JVM, no matter which operating system you're on. Step number 3, running the program using the JRE and JVM. Now, how does your class file actually run? That's where the JRE and JVM come into play. The JRE, or Java Runtime Environment, provides everything needed to run Java applications. When you double-click your program, the JRE automatically loads and starts the JVM. Step number 4, what the JVM does. The Java Virtual Machine, or JVM, is the engine that brings everything to life. Its job is to take that .class bytecode file and translate it into machine code. The actual binary instructions your computer's CPU understands. The JVM does this using something called the just-in-time (JIT) compiler, which converts bytecode to native machine code right before execution for optimal performance. Because every operating system has its own version of the JVM, the same Java bytecode can run anywhere, Windows, macOS, or Linux, without any changes to your program. That's how Java delivers on its famous promise: write once, run anywhere. Step number 5, you see the result. And finally, once the JVM executes the translated instructions, you see the result. In this case, your console prints "Hello Java." It may seem instant, but behind that output, Java just went through multiple layers, from the resource code you wrote through compilation and bytecode execution, all the way to actual machine-level instructions. In short, you write code using the JDK, you run code using JRE, the JVM makes it all work on any machine. This combination of JDK, JRE, and JVM is what makes Java such a versatile cross-platform language. Every time you run a Java program, whether it's a simple hello world or a complex enterprise application, these three components are silently working together behind the scenes. Before we can start coding in Java, we need to make sure our computer has the right environment set up. That means installing the tools that allow us to write, compile, and run Java programs. Remember, Java is not just one single application. It's made up of several key components that work together: JDK, JRE, or JVM, as we discussed previously. It's important to understand that Java has evolved a lot over the years. There isn't just one version of Java, there are many, and new ones are released regularly. Let's take a quick look at how Java versions work and which one you should use today. A quick history of Java versions. Java was first released by mid-90s by Sun Microsystems, and later it became part of Oracle after they acquired Sun. Since then, Java has gone through many updates, each version improving performance, adding new features, and modernizing the language. Some major milestones. Java 1.0 was released in 1996, the first official release. Then was Java 5 in 2004, Java 8 in 2014, Java 11 in 2018, Java 17 in 2021, Java 21 in 2023, Java 25 is the latest version, which was released in 2025. What is an LTS version? You often hear the term LTS, which stands for long-term support. These versions are officially supported for several years, received bug fixes and security updates. For most developers, especially beginners, it's best to stick with an LTS versions like Java 17, 21, or 25. That's why you get a stable environment and access to all the modern language features. How Java versioning works. Starting with Java 9, Oracle switched to a 6 month release cycle, which means new versions come out twice a year. But not every version is an LTS version. Only every few years, Oracle designates one as LTS for long-term use. For example, Java 8 was LTS, Java 9 and 10 were regular, short-term versions, Java 11 was LTS, Java 12 to 16 regular, Java 17 is LTS, Java 21 is LTS as well. So which version should you install? For this course, I recommend using Java 25 or Java 21. Both are long-term support releases. They are stable, compatible with all major IDEs like IntelliJ IDEA or Eclipse, and widely used in enterprise environments. If you already have an older version like Java 8, that's still okay for learning the basics, but I suggest updating for modern development. How to check your Java version? You can always check which version you currently have by running this command in your terminal. For Mac users, go to the search bar and type terminal. In terminal, just provide this command: Java version, hit enter, and as you can see, my system says the operation couldn't be completed, unable to locate Java runtime. It means Java is not installed in my computer right now. For Windows users, you can hit Windows plus R hotkey and provide the same command into the terminal. If you see something like Java version is 17 or 1.8, it means you have your Java installed already. If you don't see any Java versions, like in my case, it means Java is not yet installed in your system. Don't worry, we will install it together. So, to summarize, Java is constantly evolving. LTS versions like Java 11, 17, 21, and 25 are the best for most developers. Now, an interesting fact about Java. It was originally developed by Sun Microsystems, as we mentioned earlier in this video, back in the mid-90s. Later in 2010, Sun Microsystems was acquired by Oracle Corporation, and since then, Oracle has owned and maintained Java. Today, Oracle continues to release new versions, manage updates, and oversee the official Java platform standards. That's why when you download the Java Development Kit or JDK, you often see it coming directly from Oracle's website. It's the official source. However, there are also open source builds of Java available like OpenJDK, which are fully compatible and free to use. So, whether you use Oracle's version or an OpenJDK distribution, the language and features are the same, all officially based on Oracle Java platform. Now let's set up the environment step by step. The process is about the same for Windows and Mac operating system. I'm using Mac, but you can follow the same steps on Windows as well. Let's open Google and provide the input, download JDK. As you can see, the first option is an Oracle website. Let's click on it. Currently, it shows two options, JDK 25 and JDK 21. On the top, it says JDK 25 is the latest long-term support release of the Java platform, so let's use this one. We have different options based on operating system for Linux, macOS, and Windows. And under each operating system, there are different versions as well. So how to understand which file should you download? For Mac users, click on the Apple logo on the top left corner of the screen and hit About this Mac. You will see the chip information. As you can see in my case is Apple M1 Pro. If your chip is M1, M2, or M3, you need to select ARM64 downloaders. One of these two. If you have Intel-based Mac, use x64 downloaders. And for Windows, All modern Windows with Intel or AMD chips can download any of these installers. Just pick the x64 installer.exe file right here. Is the easiest and safest option. The DMG for Mac and exe for Windows installers handle setup automatically. Compressed archives are for manual installation, usually used by advanced users. So let me go to macOS and download ARM64 DMG installer right here. Just hit save. Download the installer for your operating system, Windows, macOS, or Linux. In some cases, you might need to create an account in Oracle to download the JDK, but if it allows you to download the file without signing in, please continue. Alright, let's talk about installation. Okay, let me open it, double click, and double click again. The process is pretty straightforward. Just hit continue, install for all users in this computer, continue. I don't want to change the location and hit install. Install software. And hit close in the end. Now, when we're done, we can move the installer to the trash. We're not gonna need it anymore. Once JDK is installed, we need to set up a Java path. Open your terminal and type this command one more time. Java-version. Hit enter. If you see the same output, means you already have path set properly and you don't need to perform any actions for the path. It will most probably happen for Mac users for the following reasons. macOS automatically updates the system-wide Java path when you install the official Oracle JDK or most modern OpenJDK builds. The installer places symbolic links in the bin and Java home, allowing the terminal to recognize Java and javac command globally. For Windows users, by providing Java version command, you will see something like Java is not recognized as an internal or external command. When you install Java, the programs that run Java code are located inside the JDK's bin folder. Your computer doesn't automatically know where these programs are unless the folder is included in the system path environment variable. And here is the instruction how to set the path for Windows users. First, you need to locate Java. We already installed JDK, so during installation, you set location for the Java folder or left it default. By default, it should be something like this. C program files Java JDK 25. Now step number 2, copy the path. You need to go to JDK installation folder, copy the path of the bin directory. For example, like this, include bin folder. Step number 3, set environment variable. You need to press Windows plus S, search for environment variables, and open edit the system environment variables. In the system properties window, you need to click environment variables, and under system variables, find the select path, click edit, click new, and paste the copied JDK bin path. Then you need to click OK 3 times to save. And open command prompt, again your terminal, and type the same command, Java version, and hit enter, then Java C version, and hit enter. If both show version numbers, it means Java is successfully set up and we can continue. If you see any errors on Windows or Java is still not visible, try to repeat all of these steps. But if you still face any issues, try to Google separately or maybe find a different video how to update path for Java on Windows. Alright, we installed JDK to our computers. Now let's discuss what is an IDE and why do we need it. When we write Java programs, we could technically use any text editor like Notepad on Windows or TextEdit on macOS, and then compile and run our code manually from the terminal. But doing that every time can get slow, confusing, and error-prone, especially as your programs become bigger and more complex. This is where an IDE, integrated development environment, comes in. What is an IDE? An IDE is a software application that provides a complete environment for writing, testing, and running code. It combines several tools in one place, such as code editor for writing your programs with syntax highlighting, compiler or interpreter integration to compile and run your code directly, debugger to find and fix errors easily, code suggestions and auto completion so you write code faster and with fewer mistakes. Why do we need an IDE? IDE makes writing Java programs much faster and easier. It helps avoid syntax errors with the real-time hints, lets us run and test code with one click instead of using the terminal manually. It supports project organization, especially when your programs have many files. For this course, we will be using IntelliJ IDEA, which is one of the most popular IDEs for Java development. It has Community Edition, which is completely free and perfect for beginners. IntelliJ IDEA provides powerful features like code completion, refactoring tools, debugging, and Git integration. Using it will make your learning process smoother and help you write clean, professional Java code. An IDE like IntelliJ IDEA is not just a text editor. It's your full toolkit for writing, running, and debugging Java programs efficiently. By using IntelliJ IDEA Community Edition, you get a professional Java environment for free right from the start. I would like to make a note here. There are many other IDEs on the market, like Eclipse, for example. If you prefer to use them instead, it's up to you, but for these lectures, I will be using IntelliJ IDEA Community Edition. Let's install an IDE. Let's go to Google and type download IntelliJ. Hit enter. As you can see, first link is from JetBrains. Let's click on it. Accept all. The first option, as you can see, is IntelliJ IDEA Ultimate version, which is a more advanced and paid version of IntelliJ. You can use a free trial, but I recommend you to scroll for the second option and download an IntelliJ IDEA Community Edition. This website automatically detects your operating system, which is Apple in my case. Even for the version, it gives you a hint on which you should use. Again, to identify your chip version, you can hit Apple logo and hit about this Mac. In my case, it is M1, so I will select Apple Silicon and hit download. Once it downloaded, follow the simple, straightforward installation process. Let me open the file, double click, then close it and search for it in your applications. Okay, hit open. After installation, let's open IntelliJ IDEA and delete the downloaded file. We will not need it anymore. I showed you the installation process on Mac, but the same procedure happens for Windows users as well. As you can see, when we open IntelliJ, it offers us some options like create a new project, open existing project, or clone the repository. Let's click on the new project. Let's give it a name Java underscore lessons. As a build system, let's choose Maven. Here is the location of the file. We can change it, but let's leave it as a default location. In my case, add sample code is checked. Let's leave it like this. Make sure your project is a Java project. And JDK, it should automatically pick up your installed JDK. If not, you can select it manually. And for advanced settings, let's just leave it like this. Don't change anything. Make sure you have the same version and hit create. New project is created now with the main Java class and some sample code on it. Let's close pom.xml for now. And as you can see, this is the main.java class. Here is the file. The right part is where we will write our code. Left side contains project structure, folders, and file. As you can see, the main folder has our project name, Java_lessons. There is an SRC folder right here, which stands for source. It contains all the folders that we will be using. All the folders or packages that we need are created already, but keep in mind that this is the common folder structure for a Java project. This code has some logic, and as you can see on line number 5, there is a green triangle on line number 5 and 6 as well. Let's click on it here and hit Run Main. The bottom part is a console. We will see the logs about the execution process and execution result. In the bottom part, we see some values and the text hello and welcome. Let's create our first Java program. Delete everything in the main method. So from here to here, hit delete and write this command. So please write this command. So it needs to be system uppercase .out.println, and in the parentheses we need to provide the string, which is hello world. My name is, I put my name, but you can put yours, and make sure that this text is in double quotes. And in the end of the column supposed to be the semicolon. And let's hit this triangle one more time, hit run. As you can see in the console, it says hello world, my name is Makita, and you will see your name. Congratulations, you have created your first Java program. As you can see, the logic is created in the class main. First of all, keep in mind that when you're creating a new Java class, it needs to start with the capital letter. As we discussed earlier, Java is an object-oriented programming language, so classes are the building blocks of Java programs. A class is not an object, is a blueprint. An object is an instance of a class. It may sound confusing right now, but don't worry, we will go into details a little later. Let's create a new package under Java Lesson 1. Just do the right click, New Package, Lesson 1. Hit Return. Inside this package, let's create a Java class program 1. Again, to the right click, New Java class, uppercase, program 1, and hit Return. There are open and closed curly braces that identify the scope of the class logic, like a starting and end point of the class. As you can see, start is here, end is here. All the logic should be written inside the curly braces. In order for your code to be executed properly, you need to create a main method first. Let's type main and hit tab. As you can see, the method is created now. So what do we see here? Package lesson 1. Package is used to group related classes together, right? Think of it like a folder on your computer. Here, lesson 1 is the name of the package or folder that this class belongs to. Why use packages? It helps organize your code, right? It prevents naming conflict between classes with the same name in different packages. So we have a keyword public. Public is an access modifier. It means anyone can access this class or method from anywhere. So we have different access modifiers like private, protected, and default, other than public, but we will cover it later. Class. Class is a keyword used to define a class, which is a blueprint for objects. Program 1. This is the name of your class. Class names in Java usually start with an uppercase letter by convention. The static void main. This is the main method, the starting point of Java program. Let's break it down. Static means this method belongs to the class itself, not to objects. You don't need to create an object to run it. Void, it means that this method does not return any value. Main and braces, this is the name of the method. Java looks for the method to start program execution. And curly braces. So curly braces used to define blocks of code. So in summary, right? Package means groups of classes. Public, accessible by everyone. Class defines a class. Program 1 is a class name. Static belongs to class, not an object. Void returns nothing. And main, starting point of the program. Curly braces, block of code. I want to make one note here. Java is a case-sensitive programming language, as we discussed earlier, so please type the same case letters that you see on my screen. Otherwise, your program will not work. IntelliJ will also show you an error if you mistype the keyword. So the main method is the starting point of every Java program. When you run a Java program, the Java Virtual Machine, JVM, looks for this exact method to know where to begin execution. So this is the standard form. The main method is like the entry door to your Java program. Without it, the program won't know where to start. So there are two ways to initiate the main method. And this is the new way, modern way. Let me show you the old way for the traditional Java entry point. Public static void main string args. So this is the old way. Let me comment it out. And this is the new way. So the new way is simplified entry point introduced in modern Java, JDK 21 plus, and especially JDK 25, right? So the starting with JDK 21 and JDK 25 continues this, Java introduced a simplified main method for small programs and beginners. This feature is part of preview features that make Java easier to start learning and writing, similar to scripting languages like Python. You can now write static void main, no need for public or string args. Java assumes it's your program's entry point automatically. You can still use the traditional version, both are valid. If you plan to share your code or run it to older JDK versions, lower than 21, use the classic one. We already executed one program in our previous Java class. Let's create another one and break it down. There is a shortcut to type it faster, but as a beginner, please try to type it manually. It will help you to remember the correct syntax. So let me show you this shortcut one more time. Just type main, hit tab. As you can see, public void main is opened. So to print something in the console, we can type system.out.println and some text inside it. Like first Java lesson, for example. First Java lesson. It takes some time to type every character, right? So the easiest way is to type this shortcut SOUT, as you can see, and then you can hit return or tab. It will open the whole statement. Then type the same. Copy it. First Java lesson and execute. Run. As you can see, in both cases, we see the proper output. Let's break it down. So, system. System is a built-in Java class that comes from the Java lang package. If we hover over, as you can see, java.lang is a package that contains the system built-in class. It gives access to system-related resources, for example, the keyboard input and the console output. Then we have out. Out is a static field or variable inside the system class. It represents the standard output stream, which usually means your console or terminal. In simple terms, system out means send output to the console. Then we have println. Println is method of the out object. It means print line. It prints the given text and then moves the cursor to the next line. If you use print instead, it would stay on the same line. Let me change the line number 9, print ln to print. And just remember, before it was two separate lines, right? If I change it to print and execute, it will be first Java lesson, because after this statement, it didn't switch to the new line. So the first Java lesson itself. This is a string literal text wrapped in double quotes. It is actual message you want to show on the screen. And don't forget about the semicolon. The semicolon marks the end of the statement. Every executable line in Java must end with a semicolon. So we have multiple ways to run the program. The first one is to click the triangle next to the class name right here. The second one is click triangle next to the main method here. Then we can click triangle on top on the right corner right here. We also can do the right click and hit run program. Also, we can do the shortcut like the hotkey. If we hover over, we can see that Control Shift R will execute the same program. And also, we have an option in the top menu. We can do run and run. All of these 6 options can help us to execute the program. So we executed our program and saw the output in the text in the console. What will happen if we provide numbers without double quotes? Let's try. For example, 7 plus 3 and execute the same. Here there are no quotes, so Java sees 7 plus 3 as a math expression, not a text. Java calculates the sum. 7 plus 3 equals to 10. Then it prints the result to the console. Now let's copy the same statement, but add double quotes. And execute one more time. So 7 plus 3 in double quotes, it prints exactly the text 7 plus 3. Data with double quotes considered as a string data type and without as an integer. We will go through different types of data in Java later. Now let's discuss Java naming conventions. Naming conventions are standard rules that developers follow to make Java code consistent, easy to read, and maintainable. They don't affect how the program runs, but they help you and others understand your code faster. For now, we will cover class, method, and package naming conventions, but there are more. We will cover them later. So let's start from number 1, class names. So we have a rule. Always start with an uppercase letter. If the name has multiple words, for example, student info, we need to capitalize each word. It should be described that the class represent. For example, right? Public class student info, public class employee details, and public class bank account. And take a look on the example which we need to avoid. In first case, public class student info, what's wrong with it, right? It's all lowercase. We have 2 words, but each and every word supposed to be in uppercase, and it's supposed to start from the uppercase letter as well. Then public class bank account. We have underscore, and we're trying to avoid underscores in the class names. Then let's talk about the method names. We have a couple of rules here. It needs to start with the lowercase, right? As you can see, print message. First word print starts with the lowercase. We need to use camel case, capitalize the first letter of each new word after the first, and it should sound like an action or behavior. For example, print message, calculate total, get username. And here are a couple examples we're trying to avoid. As you can see, print message, the wrong casing. First word is uppercase. We need to follow this convention for class names, but not for method names. and underscores, right? We're trying not to separate two words with underscores in the method names as well. And package names. As you can see, it needs to be all lowercase. We're trying to use reverse domain name convention to avoid conflicts. For example, if your website is gntcreator.com, my package needs to start with the com.gntcreator. And here are a couple examples, right? As you can see, package com.gntcreator.lesson1 or .example.javabasics, and we're trying to avoid uppercase letters. Now let's talk about something super simple but very important: comments. Comments are notes that we as programmers write in our code to explain what the code does. They don't affect how the program runs. Java completely ignores them when it executes your code. What are comments used for? You need to use comments to describe what your code or logic is doing when you leave in a note to yourself or your teammates, or where you temporarily disable parts of code during testing. We have different types of comments in Java. Let's start from the single line comment. Let me type the regular one line comment. So it starts with the double slash, and everything after it on the same line is ignored by Java. Okay, as you can see, I added this comment, and now the first statement is grayed out. As you can see in the console, it says first Java lesson, right? Let's try to execute the same method. And just because I commented out, now I don't see the first statement. So this statement is not executed by our Java program. So where to use this kind of comment? For short explanations or quick notes, or to comment one part of the code. Let's check the multi-line comment. And here is a syntax for multi-line comment. As you can see, it starts with a slash, then star, and then everything which will be inside until the next star and slash happens will be considered as the comment. Multiple line comment. When should you use this multi-line comment? When you need to describe multiple lines of code or a block of logic. Then we have a documentation comment. It starts with the one slash and two stars, and it is used to generate Java documentation. For example, we have our class, public class program1, right? Let's create this comment here, slash two stars, and close it. So here I can type something like this: class represents a simple Java program. Author, my name and last name, and like date, for example, 2025. And as you can see, it doesn't have a gray color, it has a green color. So this is the professional way to document classes, methods, or API for the professional projects. So again, to wrap it up, right? We have a single line comment, we have a single line comment, we have a multiple line comment, and we have the documentation comment. Let's execute the program one more time. And as you can see, absolutely no difference. All of this text is not considered during the execution. And that's it for today's lesson. Great job making it all the way through. In this video, we covered a lot of important basics: what Java is and why it's such a popular programming language, the key components like JDK, JRE, and JVM, how to set up your Java and IntelliJ IDEA environment, how to write, compile, and run your very first Java program, Plus, we talked about naming conventions and comments, two things that will make your code clean and professional from the start. If you have followed along up to this point, you now have everything you need to start writing real Java code. In the next video, we'll dive deeper into Java syntax, explore variables, data types, and operators, and start building the foundation for real-world coding. Also, if you're interested in learning software testing and automation, check out my book on Amazon, Software Testing Unlocked: The Beginner's Guide to QA and Automation. It's a 20-step journey from beginner to your first QA job. It's a complete roadmap designed to help you start a real career in QA and automation testing. Don't forget to subscribe to the channel, like this video, and turn on notifications so you don't miss the next lesson. Thanks for watching. This is GNT Creator. I'll see you in the next video. Bye.